Good morning, students. Today we will learn banker's algorithm, which belongs to this deadlock chapter. The resource allocation graph is not applicable to a resource allocation system with multiple instances of resource type. That is, resource allocation graph, which we studied in the deadlock avoidance, it is not possible to detect the system is in a safe state or not if there are multiple number of resources are there of same instances. It is not possible to recognize the system is in the safe state or not by the resource allocation graph. It is the deadlock avoidance algorithm. The name was chosen because the bank never allocates more than the available cash. This algorithm is commonly known as banker's algorithm. So this banker's algorithm is mainly for the deadlock avoidance, where we have to decide that the system is in a safe state or not. The following are the requirements for the deadlock avoidance. So the maximum resources requirement must be stated in advance. The processes under consideration must be independent. There are no synchronization requirements. There must be a fixed number of resources to allocate. That is, before going to this deadlock avoidance algorithm, that is the banker's algorithm, the number of resources are fixed. Next, number 4, no process may exist till it releases the resources it is holding. So basically, this algorithm checks that after allocating the resources, will the system be in a safe state or not. So this is our main objective, that after allocating the resources to the processes, will the system be in a safe state. So we have to check it by using the banker's algorithm. In the banker's algorithm, the name was chosen because the algorithm could be used in the banking system to ensure that the bank never allocated its available cash in such a way that it could no longer satisfy the needs of all its customers. It means resources, in this case the resources are the money. So suppose bank have a fixed number of available cash, so it can't serve its customer more than the available cash. So that resource cash or the money, that is fixed. Banker's algorithm supports multiple instances. Each process must a priori claim to maximum use. When a process requests a resource, it may have to wait. When a process gets all its resources, it must return them in a finite amount of time. So what are the data structures for the banker's algorithm? So first one is the available. It is a vector of length m, indicates the number of available resources of each type. That means how many numbers of resources that are available, it is represented by this available. Next is the max or maximum demand. It is also a n by m matrix, defines a maximum demand of each process. Next one is the allocation. It is also an n by m matrix which defines the number of resources of each type currently allocated to each processes. So also the need matrix, the need, this one need, it is also a n by m matrix, indicates the remaining resource need of each process. So need we can calculate is need is equal to max minus allocation. In the banker's algorithm, there are two algorithms. One is safety algorithm, another is resource request algorithm. So these two algorithms we have to execute, and using an example, obviously we'll describe this using an example so that we can better understand the algorithm. So this is the example of the banker's algorithm. Now in this case 5 processes are available. These things are declared, that is P0, P1, P2, P3, P4. These 5 resources are there. This is the allocation matrix, that is the how many number of resources that are allocated to this resource A. For P0 it have 0 number of resource A, it is 1 number of resource B, it is 0 number of resource C. And this is the maximum demand, that means P0 can request the resource A maximum 7 unit. P0 can request resource B maximum 5 unit, and P0 can request resource C maximum 3 unit. Already total number of resources, there are 3 type of resources, and the resources are fixed. That is, the A resource have 10 instance, B resource have 5 instance, and C resources 7 instance. And for example, here the resource A in the allocation matrix, 2 is allocated to the P1, 3 resources are allocated to P2, 2 resources are allocated to P3. So remaining resources are for the available matrix. I am coming to this. Now if I ask you that P4 have the allocation 0, 0, 2, what this means? This means P4 have 0 number of resource A, P4 have a 0 number of resource B, P4 have a 0 number of resource, P4 have 2 number of resource C. Similarly 4, 3, 3, what this means? P4 have a maximum demand for the resource A is a 4, P4 has a maximum demand for the resource B, it is a 3, P4 have a maximum demand for a resource C, it is also 3. Next, according to the safety algorithm, you can see here, first let work and finish be vectors of length m and n respectively. Initialize work is equal to available and finish I is equal to false. So here you may look, there is a work, there is a available. So what is the available means? Means the total number of resources after allocation, what are the available resources are there. For example, total number of resources are available for A. I already told you that here total resource A is 10 instances, that is A is 10, B is 5, C is 7. Now, how many of resource A are available? Look at this allocation matrix. For the resource A, 2 number of resources, 3 number of resources are blocked by P2, 2 number of resources blocked by P3. So 2 plus 3 plus 2, 10 minus this 2 plus 3 plus 2. That means only 10 is the total of resource A. So right now 3 number of resource A are available. So I am writing here in the available, that is 3. For example, B, total B is 5. 5 minus what are the allocated? 1 is for P0, 1 is for P3. That means 5 minus 1 plus 1, that is equal to 3. So available is equal to 3. And for C, it is 7. What is 7? 7 is total number of resources minus 2 plus 1 plus 2. What is this 2 plus 1 plus 2? Now, for C, P2 is blocked, 2 resource type C, 1 P3 is blocking, 1 resource type C, P4 is blocking 2 resources of type C. So 2 plus 1 plus 2 here. Now available C is right now, this is 2. So right now what information is available? Now there are 5 number of process, there is an allocation matrix, there is a maximum matrix, max demand matrix, and also are available. These are 3, 3, 2. After that we have to find need matrix. So what is that? Now the content of the matrix need is defined to be max minus allocation. So how I am getting this need matrix? Now max minus allocation. So what is a max? So already we have allocation matrix and max matrix here. So max is here, allocation is here. So max minus allocation. For example, this is 7, this is 0. 7 minus 0 is 7. This is 5, this is 1. 5 minus 1 is 4. This is 3, this is 0, 3 minus 0 is 3. For example, say this one, 9 minus 3 is 6, 0 minus this 0 is 0, 2 minus 2 is also 0. For example, this one, 4, 3, 3, 4 minus 0 is 4, 3 minus 0 is 3, 3 minus 2 is 1. So, by this way, we are having this need matrix. So, right now, we have max matrix, allocation matrix, need matrix, available. So, right now, what is the objective? Look at here, I am writing what is the objective? To find a safe sequence. That means we have to find a safe sequence so that the system will be in a safe state, not in a unsafe. There are two types of states, safe state and unsafe state. Unsafe state doesn't mean that is a deadlock, but in the unsafe state there is a chance for deadlock. So our always objective is we have to allocate the resource to the processes in such a way so that the system will always be in a safe state. That means if we allocate the resource to the processes in such a way, suppose this is a sequence I am writing P1, P3, P4, P2, P0. If I allocate resources to these processes in this sequence so that the system will be in a safe state. So our objective is, I am writing the answer, that is this is the safe sequence. So objective is how I am getting the safe sequence? Now using safety algorithm. What is that? Using this safety algorithm, we will satisfy, or we will detect, or we will compute this safe sequence. So next thing is how I am getting the safe sequence. Now according to safety algorithm, first we have to calculate this available. Already here we got that work is equal to available, so work is now available. Need matrix, we also have the need matrix. So, and after that work is equal to work plus allocation. Now that means what? Right now what is the available? 3, 3, 2. Now we have to search that the available and the need matrix. We have to search the need of which process is less than available. For example, now what is the need of P0? Need of P0 is 743. And look at here, P0 is higher than the available, can't allocate. That means need of P0 is 743 and available resource is 332. So we can't allocate P0 right now. We can't allocate resources to the P0 right now. Next one is P1. Need of P1 is 122 and available is 332. So we can serve P1. Yes, because 332 is greater than 122. So look at here, need of P1 is 122, which is less than 332. Then allocate the requesting resource to P1. So right now, for the need for the P1, we can allocate resource to the P1. After that, what will happen? The P1 will execute and it will release the resources. And the those resources are now added with the available. So look at here, after that work is equal to work plus allocation. So right now the work is, what is the 332? Available is 332. What is the 200? 200 is allocation to the P00. That means after P1, after we allocate resources to the P1, P1 will release its resources. So 200 is added with the 332 and it's now become 532. Next, we have to search for P2. What is the need of P2 is 600. Look at here, need of P2 is 600. So and available is 532. So we can't allocate. Next, P3. Need of P3 is 011. Available is 532. So we can allocate resource to P3. Now what will happen? After execution of P3, P3 will release its resource 211. So this 211 will add it with the available, and the new available is 743. So by this way we have to continue all this. Look at here, the finish I is equal to true for all I. That means we have to continue for all the processes. If all these processes are, we can available to allocate resources to all the process, and we can get the safe sequence like this. Say P1, P3, P4, P2 and P0. So this is the safe sequence we have to find using the safety algorithm. Now this one is the first part. I told you earlier that in the banker's algorithm there are two algorithms. One is the safety algorithm and another one is the resource request algorithm. So what is that? In the resource request algorithm, look at here. Suppose now P1 requests one additional instance of resource type A and two instances of resource type C. That means some additional request is done. So what is the resource? Now one additional resource, so type of A. So 1 is here and two instances of resource type C, that is 2 is here. So request is 102. And this is the allocation and the need matrix and the available, these things already we have. So our objective is now, if P1 is requesting additional resources, is it possible to allocate that resource to P1? So for that we have to use resource request algorithm for the process Pi, where request is equal to request vector for process Pi. If request j is equal to k, then process Pi wants k instances of resource type Rj. So if request less than equals to need, go to step 2, and request less than available, go to step 3, and after that available is, we have to compute these 3 lines. So come to here. So decide whether this request can be immediately granted. We have to check that request less than need. So in the previous way, what is the request here? Request is 102. And what is the need? Need is for the P1 122. So request less than equals to need. Yes, request is less than need. Then check the request is less than available. Yes, 102, available is 332. Yes, it is also done. Then we pretend that this request has been fulfilled. So right now, what is the available? Available is equal to, look at here, available is equal to available minus request. That is 332 minus 102. What is 102? Request. That is a 102. So it becomes 230. After that, look at here, allocation is equal to allocation plus request. Allocation equals to allocation plus request. So what is the allocation? This is 200. Allocation, you may observe here, allocation is 200 plus request 102. So new allocation is 302. Next, need is equal to need minus request. What is the need? 122. Need is equal to need minus request, and request is 102. So what is the new need? 020. So right now we have update in the tables. So what are those? Now we have to update the available. It is 230. We have to update the allocation. It is 302. We have to update the need. It is 020. So look at here. In this case, for the additional request for the P1, we are updating this entry for the allocation, that is right now 302. You may look at here. Allocation is 302. I am writing it here. Need is 020. Need 020. 020 here. And what is the available? New available 230. 230. So right now we have this state, and again we have to check the whether the system is in a safe state or not, or it is in an unsafe state. That means if we allocate the resource to the process, will the system will lead towards an unsafe state or not, or will be in a safe state. So to do this, again we have to run the safety algorithm. So right now, like the previous one, again we are executing this safety algorithm, that is a 230, current available resource 230. So we are searching for the need matrix P0 to P4. P0 is higher, 0 to 0 is less than what? Available is 230. So what for the P1? Need is P1. For the P1 0 to 0, it is less than work, that is a 230. So it was resource allocate to the P1, and work is now work plus allocation. So after completion of P1, it releases the total resources. Then the available resource is 230 plus 302. Now it is 532. Now again we have to search what is the need for P3. Need for P2 is 302. Need for P2 is 302. It is not less than this. So allocate, we have to allocate, sorry, need of P2 is 600 and the available is 532, not possible. So next we are going for the P3, need is 011. Okay, so right now this will satisfy. So after completion of job P3, release the total resources, then available resource is 532 plus 211, 743. And again we have to continue this process for all number of processes, and we are having, or we can have checking for the system is in a safe state or not by after completion this process we got the safe sequence P1, P3, P4, P0, P2 which satisfies safety requirement. So executing this safety algorithm shows that the sequence P1, P3, P4, P0, P2 satisfy the safety requirement. Now you may do if some additional request by P4, it can be granted or not. And if we request for a P0, 0 to 0, it is granted or not. So you have to do it yourself. So in this way, in this particular chapter, we learned what is the banker's algorithm, and within the banker's algorithm we are studied that the safety algorithm and resource request algorithm. Thank you for today.